Hi everyone, welcome to Learn with Pooja. Today we are going to discuss about RAG is a retrieval augmented generation. It's a complete course. So when most people think of Gen AI, they think the model already knows everything. That's not true. Large language models are powerful, but they don't know our private data and they can hallucinate when facts are missing. That's where RAG comes in. RAG stands for Retrieval Augmented Generation. It's a way to combine AI with the real trusted data at the time a question is asked. Instead of the model guessing, we first retrieve relevant information from documents, database, or knowledge bases. And then model uses that information to generate an answer. So think of RAG as given the AI an open book exam. The model isn't relying only on memory, it's looking things up before answering. This makes GenAI more accurate, more up to date, more trustworthy, and usable for enterprise and real world applications. Large language models and their limitations. Large language models have fundamentally transformed how we approach complex cognitive tasks. They are now roughly used for writing production ready code, analyzing financial reports, translating between dozens of languages. Beyond text, complementary foundation models extend these capabilities to additional modulators, including computer vision, speech synthesis and recognition, audio processing, image generation, multimodal reasoning, etc. Most of these systems are built on transformer based architecture, enabling them to process and generate human like content across multiple domains. You can see structural limitations of LLMs. Despite their impressive capabilities, these models have fundamental structural limitations that are important to understand. No access to private data. LLMs do not have access to private, confidential, or proprietary data unless it is explicitly provided by the user during interactions. The next one is a limited context windows. Each model operates within a fixed context window, which constrains how much information it can consider at once. As a result, very long document may be expensive or impossible to analyze in a single pass, so information outside the window is effectively forgotten. The third one is a hallucination under uncertainty. When relevant information is missing or ambiguous, LLMs may generate plausible sounding but incorrect responses. Hallucination is a hallucinate facts rather than explicitly admitting uncertainty. Understanding these limitations is critical for responsible, effective, and reliable use of large language models in real world applications. The finally, coming to the RAG, Retrieval Augmented Generation, it's a abbreviation, addresses all three of these core limitations of large language models at once. It enables the model to access external knowledge source in the controlled way, work with far more information than can fit into a single prompt, ground responses in retrieved evidence rather than guesswork. How RAG works. When a user asks a question, a RAG based system follows a two stages process. One is retrieval. Relevant information is fetched from an external knowledge source like documents, databases, vector stores, etc. The second one is a generation. This retrieved content is injected into the prompt and passed to the language model, which generates a response grounded in that evidence. By separating knowledge retrieval from knowledge generation, RAG systems produce answers that are more accurate, up to date, explainable, and trustworthy. This makes RAG a powerful architecture for applications such as question answering, enterprise search, technical assistant, and domain specific AI systems. Interpreting a basic RAG architecture. At a high level, a RAG system consists of two primary components. One is retriever, as we discussed earlier already. The retriever such as a knowledge source, such as a vector store or a traditional database or written passages that are relevant to that user request or user query. You can think of a vector store as a specialized search engine that indexes your own documents and knowledge base rather than the entire web like Google. Generator. The generator, typically a large language model LLM, for example, GPT 4 or GPT 3.5, GPT 4 mini, like a different GPT models, Llama, Llama Index, so which are like LLM models, consumes the retrieved material and uses it to produce a grounded and context aware answer. When RAG is most useful, RAG is a particularly effective in scenarios where is like a knowledge is distributed across many documents. Answer requires synthesis, not simple keyword lookup. The data is too large, complex, or deserve for a human to review manually. Beyond the simplest form, modern RAG system often go beyond a single retrieval. They may employ one retriever for unstructured data, another for structured database, additional tools that call external APIs. So the large language model act as a coordinator deciding which tool to invoke and how to combine their outputs to answer each questions effectively. This modular design makes RAG system flexible, extensible, and well suited for real world knowledge intensive applications. You can see this is the one of the picture you here how the RAG will work, like user sending the request, it is going to the retriever is fetching the external source data from search engine and sending it to the generator, and generator giving the response based on the prompt and user request and context from retriever. So this is the simple basic way of RAG workflow. To now coming to the practical example, RAG code, you need to install required packages like now I'm working with the OpenAI. So OpenAI installation, Chroma DB is the vector DB and TikTok token and PIDE environment variable creation. These are the required packages I have installed. Now loading secrets. If you run this code in Google Colab, you save your OpenAPI keys in the secret and access it by it. So storing secrets and API keys using this code. So OpenAPI key is required. If you are using Anthropic API, Anthropic key is required, and Google API key is required. So based on your requirement, you can take it like API key and export it. If you run a code in Google Colab, say open API key and secret. So I'm using open API key, so I'm saving that. So building your first RAG app. You want to get started and build your first RAG based conversational knowledge chatbot. Every RAG system is built around three essential components: an embedding model that represents text as a vector store that searches those vectors, and an LLM that generate answer from retrieval. These are like a three essential components. So now we can go with like a workflow, end-to-end RAG workflow. A RAG system typically follows a two pages workflow: data ingestion and query processing. Data ingestion: before the system can answer questions, documents must be prepared and indexed. For that, the ingestion process consists of the following steps: split document into smaller chunks, generate embeddings for each chunk, store vectors in a vector database. These are the three steps we need to follow. One is like a split documents into smaller chunks. Large documents are broken into the manageable pieces to improve retrieval accuracy and context relevance. Generate embeddings for each chunk. Each chunk is converted into a vector representation that captured its semantic meaning, and store vectors in a vector database. These embeddings are stored in a vector database optimized for similarity search. So now query processing. When a user submit a question, the system performs the following steps. Convert the user question into a embedding vector. The query is embedded using the same embeddings model used during ingestion. Search the vector database. The second step is search the vector database for the closest matching vectors. A similarity search retrieves chunks that are semantically related to the questions. And third step is select the most relevant chunks. The top ranked result are chosen as contextual evidence. The fourth one is send selected chunks together with the user's question to the LLM. Both the query and retrieved context are passed to the language model. This is the workflow. You can see this is user request. User request is converting into the embeddings, and the second step is going to the vector database. In the vector database, top k relevant document chunks fetching. It is nothing but context. So prompt instructions, user request, and context. These three along all three are go together to the LLM. LLM it generate the response. So before you begin, make sure you have a following like a open API key. Open API key or Open API platform, you can generate a key and use that Chroma DB for vector storage. So this example demonstrates the following workflow by building a Harry Potter knowledge book chatbot. The overall architecture this example implements, and the retriever such a ChromaDB vector store build from the Harry Potter book and generate uses OpenAI model to answer questions based on the retriever context. So this is the workflow. Who is Harry Potter best friend? This is the user query, and going to the query into the RAG bot. So query processor and orchestrator. And now it is going to the vector retriever. Vector retriever retrieves the context, and this context is going taking back to the query processing, and then all together will go to the generator and generator send a response. This is like a augmented, and generates the response. So this is the workflow for above example. Now the first step into the RAG workflow is the text chunking. So we can take this example. This example builds RAG from scratch without framework to demonstrate how simple the core concepts are. So RAG orchestration framework like LangChain and Llama Index provided ready-to-use chunking functions, but this example avoid those dependencies to keep the implementation lightweight and the core concepts clear. Split documents into smaller chunks into overlap to preserve context. The following code demonstrate how to chunk text at natural boundaries such as paragraphs or sentence with overlap to preserve context across chunks. So first one is import path to work with the file path in a OS independent way from pathlib import path, and import ChromaDB used later for vector storage, import OpenAI client used later for embeddings and LLM calls. And the function, this is like a chunk text, is a split a long text into smaller overlapping chunks. List to store all the text chunks, and the start index for slicing to text and loop until we reach the end of the text. We'll start l- length of text and tentative end index of the chunk. Now, if we are not at the very end of the text, try to split at paragraph boundary first. If no paragraph break is found, try sentence boundary. And if the suitable break point is found, adjust the end index. So extract the chunk and remove leading and tiling white space. Only add non-empty chunks. So move the start forward, keeping overlap with the previous chunk, and overlap helps preserve context between chunks. Return the list of text chunks. This we are saving as a knowledge, Harry Potter knowledge base, and read the entire text file into a string and split the text into overlap chunks. So why we need to do chunking? Chunking prevents long document from exceeding model context limits. Overlap ensures the important context is not lost between chunks. Clean boundaries, improving embedding quality and retrieval accuracy. The second step after chunking, what we have to do? Embed and store in ChromaDB. Generating embeddings and store them in a vector DB. So this is the code. You can see import HTTP text to create a custom HTTP client. This is recommended for better connection handling with the OPI client. Creating an open API client and specifying embedding model. Here we are using a text embedding 3 small and a function to generate embeddings for text chunks and store them ChromaDB. And the final is processing chunks, collecting them, converting it embeddings. So giving like some issue, ignore that, and now going to the next. So the big picture here is each chunk text uh, is like embedding vector. Embeddings are stored in ChromaDB for fast similarity search. Metadata keeps track of where each chunk came from. This prepares your data so it can be retrieved last during user's query. Next one is the text retrieval. So the first one, what we are doing, we have done chunking, and second step we have done embeddings. Now text test retrieval. Test that the retrieval system find relevant chunks for a given question. So this is the code you can follow, like a retrieve function to retrieve the most relevant text chunks for a user question. So converting the user question into an embedding vector, this uses the same embeddings model as was used for documents. Now we are using a client embedding dot create and model embedding. We define like a text embedding small that we can give and passing the embeddings. Query the ChromaDB collection using the question embeddings collection.query and give that document. And then question here you can see, why did uncle Verenon take the family to a hut in the middle of the sea? This is the question. You can see the retrieved information from the documents. It's like a docs. So this is the result. You can see it will come like this. Most most top ranked result. this question is embedding into a vector. The vector is used to search the vector db, and the top k most similar text chunks are written, and these chunks will be later to be passed to the LLM context. That is called text generation. You can see feed the retrieved documents and questions to the LLM to generate an answer. So here questions and docs context and giving like a docs prompt, answer the question using only context. Passing the context, role is user and content is prompt. I'm sorry. And you can see this is the answer which LLM is generating. So retrieved chunks are stitched together into the context block, and the prompt explicitly restrict the model that context, and the LLM generates an answer grounded in retrieved evidence, and this completes the full RAG loop retrieved augmented generate. At this point, you have built a fully working RAG system. So you can go through that all these four steps. One is chunking, and another one is embedded, and retriever and generator. This is the workflow you can follow, and you can create a RAG system. This is about a RAG basics. In the next sessions, we can go in depth of RAG system, how we can work, and with like a different workflows. Thank you. Have a nice day.